Our last speaker for today, warm welcome Ebba Kraemer from Scaleout Systems.
Thank you, Linus.
And you're going to talk about privacy preserving AI.
That's right. Thank you so much.
I'll sneak out here and I'll leave you with the screen.
Thanks. All right. So thank you very much for inviting me here. My name is Ebba Kraemer, and I'm a co-founder and commercially responsible at Scaleout. Previously, I worked for Google in California doing product strategy, but now since 2 years, I'm back in Uppsala with this Uppsala-based startup, Scaleup, which also has its, the technology has its origin actually at Uppsala University. So we operate in the field of secure and privacy-enhancing artificial intelligence. Just to put in context, can we switch slides? There. So. It's still the previous presentation. That's cool. I can continue going on about this without the slides first. Thanks. Just to put in context how the space that we're operating in is evolving. We've heard here earlier today, and you all know the impact and the change in expectations of AI and how that has changed during last year. And when I was invited here, I wanted to see, like, is there any way that we can try and like quantify how much the expectations on AI really changed during last year? And then I was thinking, so the way that we are noticing it is through the use of ChatGPT, right, and Midjourney and all these generative AI tools that we're getting our hands on and that can change our way of living, basically. But these models that we're using now, they're owned by different companies. It's OpenAI with Microsoft, and it's Google, and it's several others. But there's one player in the background here that develops the hardware that the AI models need to run on, and that is NVIDIA. And we can see that during last year, if we look at the stock value of NVIDIA, it has quadrupled since January 2023. And then it was from a starting point when it was already a gigantic company. So that gives us an approximation of how big AI, the shift was during last year. And as I said, we're in the space of privacy-preserving AI. And here it's also relevant to look at what's happening in terms of attitude to data privacy worldwide. So we can see from the world map here that we're starting to enter a phase where almost all geographies in the world are protected by some type of data privacy regulation. We know that like Europe was early. It's been GDPR has been in play now for a couple of years, but now most of the world has some type of regulation in place. And it's not only the number of regulations, of course, that matter to look at this attitude, but also like how are they implemented? Do they really have an effect? And we can see from the graph to the right there that this is the cumulative GDPR fines that has been implemented for violations against data privacy relating to European citizens. And that has changed and is starting to take off now. From 2018, it was still in place, but didn't have much of an impact. But now, since 2021, players and especially the big tech companies are starting to feel that this is real. So yes, this is the market that we're in. And what Scaleout is doing is that we're developing privacy-enhancing technology to enable important artificial intelligence use cases. And there are several technologies that can enhance privacy for artificial intelligence, and they can be used as complements, as supplements. And we are specializing in one technique which is called federated machine learning. And I will explain a bit about what that is. And I think everyone in this room and looking will understand what this is now, given your intro explanation of what AI is. So we know this is an illustration of how normal or regular machine learning works. So you gather data from different sources and put them in a centralized data storage. And in this centralized data storage, there you can train a machine learning model for a specific purpose. And when the model performs well, an operator can make queries and obtain predictions. And the data can be basically any kind. We can imagine sensor data from self-driving cars, or private usage data from mobile phones, or image data from hospitals. And the use case that we are addressing are the situations when you don't want to move the data that you need to train the machine learning model on. You either cannot do it, you might not be allowed to due to regulations, or you just don't want to for security purposes. And the reasons for why you wouldn't want to move the data is there are more than just privacy regulations. You might have physical blockers. Now, with the involvement of self-driving vehicles and IoT, industrial IoT in specific, you have situations where you gather huge amounts of data on the edge, and it becomes impractical and it becomes hard to centralize the data, basically. So practical blockers. And then the data legislation. It's data privacy legislation of different types, and it's also regional data transfer legislation that is increasingly coming in place in various countries. China is currently most conservative with really strict data transfer law. It's hard to move data out of the country. And then it's not accessible. Right? And then it's the general category of, it might be business sensitive data, it might be sensitive for other reasons, and you just don't want to expose it more than necessary. So federated machine learning is a way to enable AI in these circumstances. And I wanted to explain how it works with this illustration. So if we imagine that we want to develop a model for being able to better diagnose cancer early, and we have a data set here containing diagnostic images that are taken at hospitals. And now this type of data is protected by patient privacy regulations. So, and that means that it cannot leave the hospital site. But still, in order to get a good model that works for prediction, you need to have a big data set. And how federated machine learning solves this is that instead of centralizing, transferring the data to a central place where you have the model, you let the data reside where it sits with the hospitals. And instead, it is the actual model that is transferred to the local site. And the model is trained here, and it will have its weights or parameters, the neurons, updated. And then it's only the updated weights that are transferred back to the central model, and there it's aggregated into a new version of the central model. And then this happens iteratively across all the local data sets. So in the end, you will have a model that has learned from all this data, but the data has never left the site. It sits within the control of the local data owner, and behind the firewalls, and doesn't need any open ports. So that is what we expect from federated machine learning. And the example I just gave you was illustrative, but we are involved in a project that is very similar to that, and it's called Assist. This is a European-based project, and it's a collaboration between research institutions, hospitals, and companies with novel technologies like ours. And the ambition is basically to try to find smart ways of enhancing healthcare. And what we're doing there is that we're looking at data which is also cancer images of early brain tumors, and the ambition is to improve therapeutics here. This initiative is led by Professor Anders Eklund in Linköping, and now using our technology, he has successfully enabled a model to be trained across 3 Swedish university hospitals. I think it's Lund, Linköping, and Umeå at this point, and this is also a project that plans to expand with great results. Another interesting collaboration that we're involved with, or like customer that we have basically, is Eurocontrol. which is the authority that is responsible for air traffic management in Europe. And Eurocontrol has identified that if they had access to the data of the airlines, they could do a lot of cool AI, like improving routes, for example, route optimization, or predicting delays in the flight network. But then it's the airlines that owns the data that they need to train the model on. But given that Eurocontrol is an authority that has trust, these airlines can trust them to own the model and let their allow the model to get trained on their data, since it can still sit in their environment. It never leaves their premises. So that is in R&D, but has promising early results also. A third example is from our everyday usage of cell phones. When you use your phone, you create a lot of personal sensitive data, not the least in relation to like text messages and chat messages that you will send, so text-based data. And there are very important and time-saving tools that you can do that are AI-based if you do allow AI on this data. But you might not want this data to be centralized up in an American cloud provider somewhere. So federated learning enables that you can have AI tools such as spam filters or next word prediction when you're writing and typing, without ever having your text data leaving the phone. Yes, this I will talk about some other time. And with that, I wanted to leave you and say thank you for inviting me. See if you have any questions.
Thank you very much, Ebba, for sharing about privacy preserving AI and federated machine learning. You gave some examples here of projects that you're involved in. How are you working? You're an Uppsala-based company. How are you working to reach out to international markets?
Great question. So we are currently focusing on the European market. And the reason for that is that we are in a similar time zone. We feel that doing machine learning and succeeding with AI is not trivial. And when you have this need of keeping the AI private and have a decentralized system like this, then it adds still a layer of complexity. So we have both the technology that we have developed, but also services that often accompanies this in the projects that we're in proof of concepts or similar things. And that makes it a little bit hard to work with Asia and US in this context. But we think we start as broad as Europe, because there's also there's not that many companies out there today still that are mature enough from an AI competence perspective to be able to adapt and enable this type of use cases. So we're kind of screening a little bit the market for like where there is relevant use cases, and also where the AI competence of the companies are at the level where they can successfully adapt this and get this into production, basically.
I'm also thinking enabler is a word that we've used today. Your type of technique could also be an enabler for industrial companies or other companies that have solutions at customers and want to collect customer data from several different customers and be able to provide better information to their customers based on everyone's data. How for those type of projects where there are a lot of stakeholders involved, what's your experience so far? What's important to succeed in this type of projects?
That's a great question. Maybe we can actually, this is an illustration, the midsection here illustrate, I think, what you were saying. So here we can imagine that you have a system developer that creates some kind of a system, a software or a machinery of some kind, and they're selling it to customers that will then utilize the systems. You could imagine like a robotics developer here, like there are some in Sweden. They're selling maybe hundreds of robots to other individual companies and entities. And here one could see the use, for example, like we heard earlier today, that if you create a model for predictive maintenance across these robots, you have the chances, if you can do that from a central perspective, you have the opportunity to get pretty good predictions. But in some circumstances, it can create a dispute actually between the system developer and the individual system utilizers that create the data. In some industries, you see that they are starting to create so much data on their own that they have the potential to create a pretty good model themselves. And then they might not want to share back the data that would be crucial for the model. And since we are a horizontal company, we're involved with many different use case discussions of AI that is being developed now. And depending on what sort of industry you look at, you can see where like that there's it's not obvious like where the AI model ownership will lie. And everyone, of course, sees AI model ownership as an asset. And then you have to sort of weigh, is it beneficial to let the sort of central system developer own the AI, or do we want to create like the crucial AI on our own? And yeah, this is under development, and it's very interesting to see where it lands. And we see different things basically.
So we might see more industry collaborations like Swish for payments or things like that.
Exactly.
Where companies in an industry start a new entity and try to utilize data.
Absolutely, that's a result of that's that same dynamic. Yeah.
Okay. And another thing that I think is on the agenda at a lot of places now is security. And since if you're using these type of models, you have sensitive data to start with. How sure can you be that the data is safe from hackers and cybercrime and things like that when you're transferring the model to different places?
No, that is a great question. Like there are lots of incentives to try and steal good AI and try and steal data, and hackers are doing that all the time, and they're developing very, very fast. So like one can foresee a future like regardless of what privacy-enhancing technology will take off and how we will see that be used in the future, then of course like the hackers will adapt to that and try to find the weaknesses and so on. But a principle that I think is good and that has kind of led the work for GDPR, for example, in that's origin, is try to adhere to data minimization principles, which basically means that like never gather excess data in the first place. Don't expose it unnecessarily. If you don't have to transfer it, don't do that. Don't create unnecessary copies of that data. And when the data has been utilized as intended, and that might be training an AI model, delete it as soon as you can. And I think if you adhere to that, then you minimize the exposure for attacks. And then you still have to be on your toes and see like what they come up with. But I think it's a good principle to start with when designing safe systems in the future.
Okay. And we have heard Uppsala University here as well. Can you tell us a little bit what's your connection to Uppsala universities and other universities, since you say you're also in a mode of developing this with stakeholders?
Yes, absolutely. So the concrete origin of Scaleout is that we had 3 of its co-founders are professors at Uppsala University in computational science, and still very active with the company. So that's basically the origin, and we've had collaboration over the years. And now when they had done, federated machine learning started in academia like 10-15 years ago, and they were on to the topic already then, and they were very early with industry collaborations. So when those industry collaborations and the technology was mature enough to go out with broader from a commercial perspective, that's also when I came aboard and started to work on that more focusedly also.
Thank you very much. Let's see if we have any questions before we break for today. No. Thank you very much for the presentation.
Thanks.
Thank you.